Hello ladies! Today I'm very happy to solve with you the energy worksheet that we did in class and started in class. So, let's work on question 1. The increase of gravitational potential energy. So I want to find delta GPE. For moving 10 kilograms, so I know the mass is equal to 10 kilograms, up to a shelf that is 1.5 meters high off the ground. So the initial is 0 meters, and what I've just wrote as h is actually h final. Okay, so here I need to first find the initial gravitational potential energy and the final potential energy. I know that the distance up is 1.5 meters. So the gravitational potential energy initial is mass times gravity times h. It is 10 kilograms. Energy is not a vector. That's why we put 9.8. Then 0 because we're at the ground. And the final answer is 0 joules. Here we go. Now, the final gravitational potential energy is mgh. The mass is still the same. The gravity is still the same, but the height has changed into 1.5. And I find the answer, and the answer is 147 joules. So delta GPE, or what they're asking us to find, is GPE final minus GPE initial. It's 147 joules minus 0 joules. And the final answer is 147 joules. 3 significant figures, so I'm good. And I wrote the unit. The answer is positive, which means the energy is increasing. Makes sense. So that's my final answer. Now, next question. Kinetic energy depends on the velocity of an object, right? Because I know that kinetic energy is half mv squared. So, velocity of an object. The height, not really. The mass of an object, yes. And the direction of motion, nope, not really. So, 2 of the above is the correct answer. The ability to do work or cause change is called energy. That was our definition that we studied in class. The ratio of work to time is called power, because power is equal to the work divided by time. Okay, so now you take your backpack out of the car. Alright, so we start here by our car. That's my initial. I hike to the top of a mountain, and then I return back to my car. So this is my final point. The question is, have you changed the amount of your backpack's gravitational potential energy? So the answer is no, because the initial position is the same as the final position. So the gravitational potential energy at the end of the journey is the same as the gravitational potential energy in the beginning. And that causes the change in the gravitational potential energy to be exactly 0. Okay? So let's move on to the next question. If you keep pushing at the wall for 10 minutes, are you doing any work? The answer is no, because work is force multiplied by distance. If you have no distance, then you have no work. And still, let's add the units, even though the answer is 0. So now 2 boxes of the same mass are lifted in the same height, to the same height. Does it necessarily take the same amount of power? And the answer to this question also is no. We can't compare the power. The power of the first box does not have to be equal to the power needed to lift the second box because it depends on time. We need to know the time to compare. Question 8. So here, it's about kinetic energy. I know that the mass is 0.5 kilograms. I also know that the initial velocity is 5 meters per second and the final velocity is 0 meters per second. I want to find the change in the kinetic energy. So, let's start with finding the initial kinetic energy. It's half mvi. Half times 0.5 times 5 squared. And the answer is 6.25 joules. The final kinetic energy is also half mv final squared, half 0.5 0 squared, which is equal to 0 joules. So now what we want to find, it's the delta KE. Delta KE is KE final minus KE initial. It's 0 joules minus 6.25 joules. The answer is negative 6.25 joules. Now remember, energy is not a vector. So that negative sign doesn't mean that it's going to the right or the left. It means that we're losing kinetic energy. Negative change of energy means energy lost. And that makes sense because the pi is slowing down and eventually stopping. So it's losing its kinetic energy. Number 9. How much power is required to push a 48 kilogram couch 3 meters to the right with a force of 500 newtons to the right in 6 seconds. So here's my couch, my force is to the right, this is the distance covered, that's the direction of motion, and I want to find the power. The power is equal to the work over time. I have the time, but I don't have the work. So first I need to find the work. In this case, the force and the direction of motion are the same. So we use the formula W equals to F times D, which is equal to 500 multiplied by 3. The answer is 1,500 joules. That's the work done. So the power is the work over time. It is 1,500 joules over 6 seconds. They actually gave me 2 significant figures, not 3. And the answer is 250 watts. Question number 6. Here we have a box that is being pushed by Donesia to the right. And also by Lizzie to the left. We have the force of friction. Friction is to the left, and we know that because the direction of motion is to the right. Friction is always opposite to the direction of motion. That's friction. It opposes motion. That's what it does. The box is somewhere around the earth, so we have W, and it's on the floor, so we have normal force. These are all the forces that are applied on the box. That's how we do the free body diagram. Question B is asking some solving. So we need to write what we know. We know the mass. So I listed everything I know. As I said, the mass, force by Donesia, force by Lizzie, negative because it's to the left, kinetic friction, negative again, and distance. The question is, what is the net force? We add all the forces on the x-axis. So, the forces are force by Donesia, force by Lizzie, and force of friction, which is 31, negative 11, negative 4.5. The answer is 15.5 newtons. Now, what is the acceleration? We are accelerating, so we use Newton's second law, F net equals to ma. Now, F net, we just found it, is 15.5, ma is 12, m is 12, and a is a variable, so a is equal 1.29 meters per second squared. It's positive, and I used 3 significant figures. Now, what is the work done by Lizzie on the box? So the work by Lizzie is negative F times D, just because Lizzie pushes to the left and the direction of motion is to the right. So it's negative 11 times 2. I write the forces in absolute values. And the work by Lizzie is negative 22 joules, which means she's not contributing to the motion. She's doing negative work. While the work by Donesia is F times D, because she is pushing to the right and the motion is to the right. So Donesia does 62 joules. Positive work. She's contributing to the motion. The work by the friction is again negative the friction times D, because the friction is opposite to the direction of motion. And the work by the normal force is simply 0, because the normal force is perpendicular to the direction of motion. And I can say exactly the same about the weight. Now let's find the net work on the box. And here we need to just add the work of all the forces acting on the box. So I add up all the work of all the forces acting on the box, and because work is not a vector, I do not need to worry about axis. I just add all the work that's on the box, and the answer is 31 joules.